very happy to be here today with Tim Harwood, who's Head of Programme Management for the H21 Project, which is one of the big initiatives being driven by Northern Gas Networks here in the UK. I'm actually going to hand over to Tim and ask just for a little bit of background on how have you ended up at the helm of this? What was your background before? And just to give a bit of a flavour about how you've arrived at this point and spearheading quite an exciting project.
Yeah, thanks, Alex. I've just in August this year tipped over actually 4 years in the gas industry. I started as an apprentice with British Gas in 1980, which seems a long time ago now. And over a varied career, I've done various different roles, mainly in operations and maintenance. I did have a spell of 8 years at National Grid, which I thoroughly enjoyed, up to 2012. And then in 2012, I came back to Northern Gas Networks as sort of head of construction. So I do a lot of project management, as I say, in operations and maintenance. I've always been really interested in sort of green side of things. And when hydrogen was coming more and more on the agenda, I put myself forward to be the sort of project lead, if you like, for developing the hydrogen projects. And now I've ended up as H21 Project Director, and I'm also the overall director for HyDeploy 2, which is a 20% blending project that we potentially might get a chance to have a little talk about later.
Yes, we'll talk about that blending project. I think is an interesting kind of on our way out of the main H21 discussion. So let's kick in with the project then. So the one thing I did want to add was that one of the reasons that I reached out to you was actually the H21 project was something that and this is honestly true. I'm not just saying this to kind of make the podcast sound like it's a thing when it's not a thing, but one of the listeners who had been in touch about the podcast had said that H21 was a project of interest that they really wanted to hear about. And then since then, I suppose once you have someone poking you about it, someone else has mentioned it, I've been reading about it. I mean, it's really gaining a lot of interest in the UK and Europe as one of the kind of key hydrogen projects. So hydrogen as an opportunity to transition. So why don't you tell people who won't necessarily be aware of it yet, who may be in other countries or in different sectors, that's the headline on what H21 is trying to achieve or trying to prove?
H21 is a suite of projects that's aimed at basically demonstrating that existing gas distribution networks can be repurposed to carry 100% hydrogen. Now that sounds easy, but it's actually quite difficult to go through all the safety-related and research and development activities that we need to do. So the project is split up into a number of different phases. It's been in progress since 2018, and it's not due to complete till the end of 2021. So we've just finished phase one, and now we're moving on to the second phase. It's government sponsored in essence because our regulator, Ofgem, have given us the money to do this research on behalf of the gas industry. But, in essence, we're really doing it on behalf of the UK, I suppose, and the government. And so the first phase of the H21 project is all about demonstrating that if you transferred over to hydrogen, would the leakage be any different to what it is with natural gas? Would the consequences of gas leaking into buildings and how you do operations and maintenance and repairs on pipes, would that be any different with hydrogen as it is with natural gas? We've built 2 test centres and worked with 2 industry-leading partners on doing this research. So there's the Health and Safety Executive Science Division, which is based in Buxton, in sort of central England. And then there's DNVGL, which we're doing consequence testing with in their site at Spade Adam in Cumbria. So we've built some purpose-built testing facilities, taken lots of assets out of the ground, tested them to see if they behave any different with hydrogen as they do with natural gas. The end game of everything is being able to demonstrate that we could operate a hydrogen network just as safely as we do now with natural gas. Within the gas industry in the UK, we're very proud of our safety record. We have a 99.99% resilience, so people are unlikely to ever be interrupted and have their gas supply turned off unless they obviously want their supply replacing or they've actually asked us to come and do it. And we've got a really great safety record as well, so we've got a lot to live up to with hydrogen, and we want to do as much research and development as we can to try and, I suppose, look at any other aspect that might be out of the ordinary and anything that's different than it is with natural gas. So that's really sort of what phase one is, and there'll be a report coming out for that in the new year, and we're going to be organising, doing some webinars and things like that. So if people are interested, I'd watch out for that, and maybe we could give a shout out to the sort of I think it's www.h21green is the website where we have H21. So there'll be details of the webinars on there.
I'll add that to our show notes. So for anyone listening who wants to look that up, wherever you look at this, whether it's our website or Spotify or Apple, if you go to the show notes, you'll find that link there.
We just started phase two, which is more dealing with sort of how we do operations and maintenance on the network. So how do we go and fix hydrogen leaks? How would we extend the network? How would we replace components and parts? And also, how would we do all the policies and procedures and all the various standards and things that there are? So there's various different streams of research going on, but at the end of it, it's all to prove that we can operate our network safely and so that we don't impact on the public. We've done a lot of social science and research with Leeds Beckett University looking at the acceptance of hydrogen and how that had impact on the public. So the other side of it is not just the safety related things, it's looking at how the public acceptance would be of hydrogen. What are their views and how would they feel about hydrogen coming into their homes? So that's also been really enlightening and interesting. And that research is also going to be part of our sort of launch of the phase one report, giving you sort of outcomes of that. So,
did any surprises come out of that, or I don't know, is it what you think it might be, that yes, it'll take just a bit of education and showing people how you've demonstrated and tested, or were you pleasantly surprised by what you heard? What sort of things came up?
I think we were pleasantly surprised actually. The main outcomes from the research are really that. Then we're trusted by the public. So the public trust gas distribution networks to do the right thing. They believe that if we're going to change the fuel that goes into people's houses, that we will have done this type of research that we're doing now, and that we will make sure everything is safe and that we're not going to put them at danger. So that's really good that they have a high level of confidence in the work that we do on a day-to-day basis. The two things that stand out really from that research is they don't like disruption. Of any type, and that's very, very interesting when you're thinking about things like potentially hydrogen-ready boilers and how you would change people over and do a conversion. Yeah, they really don't like disruption. And the other thing is they don't want it to cost any more money than it would now, which is probably an obvious one. But the interesting thing on the back of that is we did ask them, look, if this is going to decarbonise the UK, if it's going to help save the planet, what would you feel about a small increase in costs? And funnily enough, most people were open to a small increase in the cost of the service if it meant that they could sort of say that they were helping towards decarbonisation. Only a small percentage, but it's still interesting to think that people do put actually a premium on feeling good about that they've done something to help save the planet and that they've helped decarbonise. So that's quite interesting, actually.
Yeah, I think that, to me, sounds. I might have expected perhaps more a larger kind of contingent of people who felt a bit more strongly about health and safety. But I guess it's also to do with the way that, as you say, you have that trust factor. You already operate a system which has health and safety implications, and people trust the work that you've done and the delivery. So you are coming from you're a known entity entering the space. And I wonder if it would be different. That's a question for another time, maybe. But if it was a new market entrant, obviously that then would have massively different connotations, I guess.
Yeah, we're governed by very strict sort of rules and regulations, and again, we're in the 99 point something percent attendance that gas escapes within an hour and things like that. So people trust that we do provide a good service, and they sort of expect it. And we pride ourselves on being able to do that. That is one of the big things in the gas industry. If you ring up the emergency number, if you smell gas, then we will respond. And that'll be no different in the hydrogen world. And it's a great foundation to build on, and a good reputation. And of course, we want to do everything we can to maintain it, which is why the research has to be very thorough, and we don't leave any stone unturned, really.
Okay, so you gave us a good kind of overview of the goals of the entire project. We've heard a little bit about the fact that you're now kind of moving into phase two, or knee deep in phase two? How would you describe it?
Yeah, we started phase two earlier on in the year. Obviously, we've had a little bit of a setback because
Because of the plague.
yeah, so we're a little bit behind. We're not too far behind actually, but we won't complete that research until the end of 2021. And at that stage, we are expecting to sit down with our regulators, the health and safety executive, and get an agreement from them that we can actually do live trials. So we can actually go to putting 100% hydrogen into people's homes out there in the public domain, and that we'd carry on doing some trials to see how that went, and to sort of take it from the research and health and safety side to more actually supply chain development. And so that helps us to think about hydrogen production, and it helps us to think about end uses and appliances and things as well.
So phase three is that. Phase three is the live trial, the kind of the looking at what the appliances are that people will be bringing into their homes, how the wider infrastructure plays in together.
Yeah, that's right. Phase three, we're hoping to start fairly small, so potentially something like 50 homes. They would all be visited and have all the appliances changed over to hydrogen appliances. We'd obviously set up some sort of a production facility as well, and take the existing infrastructure out of the gas network and just convert it all over to 100% hydrogen. So if that's successful, and could probably run for potentially about 12 months, then we'd start increasing the number of homes that were on 100% hydrogen, and gradually grow that out to potentially 600-700 homes, something like that. And that's a trial to really demonstrate that all the research that we've done over the past few years is viable, and it's a practical demonstration of all the scientific research. At the end of phase three, we hope that then we'll be able to do pilots where, you're talking about a few thousand homes then, and that is really a practice for the actual rollout and conversion. And this will be across the whole UK. So I see trials starting potentially in 2 locations, one in our Northern Gas Network area, and the other one in Scotland in Fife. And then from that, it will slowly grow, and there'll become more and more trials and pilots, and then roll out across the country over the next 10 years. So we do feel a great responsibility to get this going and prove that we can do it. But it will lead to, hopefully all 23 million gas consumers in the country having a hydrogen supply, which is amazing.
So at the moment, you said kind of the backing has been government and regulatory cash that's sponsoring this. Phase three, I'm imagining, has some different partnerships that would be required, and is it different funding as well? I mean, as in different sources of funding, or would that still be government backed because it's still pilot phase? How would that likely work?
I think phase three will probably still be government backed, but we are getting into the realms of talking to larger companies about hydrogen production, talking to appliance manufacturers about sort of mass production of appliances. And there will come a stage, once we've proved that we can do 100% hydrogen in people's homes, that the safety side of it moves to one side, and then it becomes more of an economic argument. People need to have freedom of choice, so that if they don't want to have a switch over from a gas supply to a hydrogen supply, then there are heat pumps or electric options and things like that. So it will come more down to market forces. And if we don't stimulate hydrogen production, we will never get the cost down to where it reaches an economic tipping point. So we do feel as well that apart from doing the safety side and the trials, we have to stimulate production. And we will end up working with partners to get the production off the ground and to set up hydrogen networks. And hopefully then that will lead to the cost coming down. As with anything else, the bigger it gets and the bigger the scale is, you're more likely to have a more cost-efficient cost base, and you just produce the product for a cheaper price. So, yeah, it's one thing will sort of lead to another, hopefully.
Okay, well, as I definitely mentioned to you, and other people will know, most of the work that I do, I suppose, is with the industrial group, the industrial side of things. So I'm imagining Northern Gas Networks, you must supply gas in some of the most densely industrial areas in the UK. So are you already, has that been eliciting interest from those industrial clients? Are you getting inbound inquiries about how this might benefit industrials at some point, or are you sensing people just sitting back and maybe observing how it goes? Tell me a bit about how the industrials are reacting or maybe engaging around this.
There's been a great deal of interest. We've actually been talking to somebody earlier on today about a large-scale project with our colleagues at National Grid, and there's a tremendous amount of interest. And you're right, within the Northern Gas Networks geographic area, the Humber cluster and sort of Teesside are the two big sort of industrial areas. There's a lot of talk in government about providing some stimulation to get those off the ground. It's highly likely that while the trials are going on a small scale to decarbonise homes, they'll also be looking at decarbonising industry. And it could be that some large steelworks, power stations, or potentially glassworks and those sorts of really large users could actually be the first to the party, that they're the first ones to get hydrogen supply. And then on the back of that, there's additional excess supply that then can be fed into homes as well. So in an ideal scenario, you would grow an industrial cluster out, start picking up all the large industrial users, but then you're picking up the sort of housing estates and the urbanisations around as well. And it grows out from the industrial clusters, and then they join together. So an example of Humber and Teesside, in the big scheme of things, they're not that far away from each other. And if those two industrial clusters grew out, they could potentially join together. There's a very large underground gas storage facility sort of halfway in between Teesside and the Humber as well. So as a model of how you might do it, and it's not the only one in the country, but obviously it's the one that Northern Gas Networks is working on. We have lots of discussions with local authorities and hydrogen producers, hydrogen manufacturers, and people who want to get involved on a sort of daily basis, really. And of course, Boris's announcement last week has only sort of stimulated it even more, and we're almost in danger of being overrun by it. But actually, it's a great problem to have. It's taken a long time to get hydrogen on the agenda and get people talking about it, but now it's really got momentum.
So the current, again, just coming back to H21, that's purely domestic, purely looking at its feasibility in those different stages for domestic supply. What is it likely that there would be a similar project for industrial supply, or most of these learnings, do they apply to industry or industrial networks and scenarios as well? How might that play out?
Yeah, it's a bit of both, really. I think the H21 project does cover gas distribution networks, which have anything from power stations down to sort of shopping centres, your fish and chip shops and your supermarkets, and then your houses. So they have a real sort of varied sort of cross-matching of all sorts of different types of users. I think running in parallel with the H21 project, there's also things like the industrial fuel switching project and projects that other gas distribution networks are working on that are trying to look at, how could you really convert a power station, or how could you convert a steelworks? Because I think the government really like the idea of that, because in one hit you can make a massive change of how much you can decarbonise, whereas homes will be more of a slow burner. And decarbonising homes will really get going in about 5 years' time, but it could be another 10 years or more before it's completed. Whereas if you do a couple of power stations, or like I say, a couple of really large industrial users like chemical works or glass works, you make an instant sort of impact. So I think there's going to be a lot of money put into that, and it's part of Boris's 10-point plan is that they stimulate sort of large-scale hydrogen production so that we can start decarbonising these really big industrial users.
Do you have a sense, and it's fine if it's just not clear yet, but do you have a sense of when other investors or investment groups might be brought in or needed to come in? Or for now, is it just, no, we see as far as we can with the government money and we'll see what happens next?
Yeah, I think there are big players like Equinor and Uniper and Engie are all, they're already looking at where can we invest, where can we get together and form consortiums, and how can we work with the government and with the gas networks to bring everything together. So we have a lot of discussions. I think the investment is there. These things take a long time to come to fruition. So at the moment, we're doing what we call FEED studies, which is just like front-end design, feasibility studies, if you like, of how it might work. But there's some serious discussions around the industrial clusters in Humber and Teesside and over in the northwest with the HyNet project, in Manchester and Liverpool. It's really very serious sort of discussions with big companies about how we can actually make this work. So most of the big players are already on board with it. And even your BPs and Shells, they are now coming round to think, yeah, let's set up a hydrogen division and let's look at how we can sort of switch over. And they see the end of fossil fuels, and they are big companies and they want to be part of a new future.
So that brings me into then the economics kind of piece of this, because probably for most of the companies, whether they are the big integrated energy companies or whether they're smaller organizations, but those that are looking to get involved with this, everyone right now cares about the economics of hydrogen. It's often the thing, actually, far more, very rarely do I read anything about the security or safety element. It's really all about, is it actually investable? Is it actually going to be economically viable? Or rather, when is it going to be economically viable? So what's your sense of, if nothing changed, the economics of this, but we think by doing X, Y, Z, the economics could be something else? Tell me a bit about that.
Yeah, I think it's all about scale, really. There's no getting away from the fact that because there's a small amount of production at the moment, that the cost of natural gas per se is much less at the moment than it is with hydrogen. But on the other hand, if you look at the government research that's been put into not doing hydrogen, and instead the alternative is an all electric system, that's been proven. It's tens of billions of pounds a year more expensive to just have an all electric system. What we need is a well balanced whole systems approach, as we call it. So we're balancing off things like constrained electricity. So we talk about the economics of it and the cost, but at the moment, there's hundreds of millions of pounds worth of free electricity that is not being used in this country because it's what we call constrained. So like wind power that can't be used because it's not required by the national grid, that could be used to create hydrogen. And then the hydrogen could be stored underground. And ultimately what you're doing there is creating a gigantic battery. You are storing energy for the future. That is actually how you get the price down, because you're using a commodity that would actually not be there in the first place. It's electricity that is, I won't say it's free, but when they build all these giant offshore wind farms, there'll be times when that electricity is not required. Now, if you've got a product that you can't sell, then that product is going to be more expensive in the long run. If you can use that product, like during the night when there's a low demand for electricity, to make hydrogen, store the hydrogen, then use the hydrogen at the peak times during the next day, in the morning and at tea time, then you've got an efficient business model there. And so we are working with the electricity companies to think about how we can produce hydrogen at a lower cost than it is at the moment, to get it down somewhere near the price of natural gas. I think it's going to take probably at least 10 years, if not more, before the price is sort of comparable. But there have been studies done that say, by the time we get to the 2030s, it will be comparable in price to natural gas. And of course, then, we should have an efficient network and system that's well balanced, will work hand in hand with the electricity companies. And, we'll be getting everything done for the least cost option. It's sort of the most efficient way of doing it. And by that time, the price should be comparable, as I said.
It's interesting going back to that point about unusual or not previously done styles of collaboration, and that it's not like the technical issues. Yes, the technical issues exist, and yes, the financial issues exist, but there's also this kind of third arm, isn't there, of how we create collaborations that are really effective between partners that probably typically wouldn't have got involved with each other before.
The only way we're going to make this work if we all collaborate together and work together. It's not a sort of an arms race between the gas industry and the electricity industry, about who wins the decarbonisation battle. It's about working together. And, if we can balance peaks in the electricity consumption and they can balance off our peaks as well, that's actually better for customers. At the end of the day, that's going to mean everyone has a lower bill, whether it's gas or electric. And you have to work together to be able to do that. there may actually be a time when there's like a joint control room, if you like, and the whole country is being balanced out to get the most efficient use of energy, no matter what it is. So the electric's getting turned down at certain times so that we don't have overproduction, and the hydrogen's creeping up, and the same way the other way around. So we are having lots of discussions about that. We do work with the electricity companies, but we also need to work with hydrogen producers as well. What we have at the moment is a lot of the gas coming from offshore. So a lot of the natural gas comes into the country from gas fields around Europe, and a lot of it, especially from Norway. But obviously, we're not going to have that. We're going to have hydrogen being produced inside the UK, more likely than not. So yeah, we'll start off making the hydrogen from natural gas probably, but we need to get electrolyzers off the ground and get them built up to be sort of the scale that we need, so we can produce as much green hydrogen as possible. So how are we going to do that, and who are going to be the big hydrogen producers? Is it going to be existing sort of industrial companies that sort of get into doing that, or are we going to have new players coming into the market? Will there be any new technologies and inventions that come up with a new way of producing hydrogen? So, we realise we need to eventually move away from producing hydrogen from natural gas, because we have to capture the carbon and then pipe that out offshore. And it's almost like you have to create two systems when you do that. So that's why the cost is more at the start. If we can get the cost of electrolysis down, you're making hydrogen from water. Your byproduct is oxygen. And when you use it, it produces water again. So that is the place where we want to get, because everyone understands and can easily think that is a great solution. And we only do that by building up a really strong supply chain. So it is really important that hydrogen production is probably the most important thing over the next 10 years, once the safety-related aspects have been proven.
So talking with gas producers and shippers now, at what stage do they start to fit into this process? Because obviously what you're doing now is small scale, it's still early testing, but I think I can understand from what you're saying what they're needed for, clearly, which is the right method of production, the right price of production, and getting that price down over time. When do they start really getting involved in a project like yours?
I think as soon as the trials are finished, which will be probably 2023, 2024, something like that. At that point, we will be looking to do pilots, and I'm sure some of the industrial fuel switching will be ready to happen by then. We will really need to have people setting up quite large hydrogen production plants and things by then. At the moment, we're going to do our own production as part of the trial, but we're a gas distribution network, and we don't produce the product, we only transport it, and we don't really want to get into that either. So that's, again, why we're having lots of conversations. So I see from the sort of midpoint of the decade through to 2030, it really ramping up with large plants at the start that, as I say, make hydrogen from natural gas, but on the back of that, smaller plants that make it from green electricity, and they grow and they eventually overcome the sort of natural gas reforming plants, and they start to shut down, and we go for more green hydrogen right across the board. So yeah, it's a lot closer than people think, actually. When people talk to me, they say, well, there aren't going to be any hydrogen ready boilers manufactured at scale till 2030, you won't have production. But actually we will. We're actually targeting a policy decision by government on multi-billion pound investment by 2025. And if you think about that, 2021 is just around the corner. That's not far away in industrial terms. That is only like a heartbeat, really, to be fair. So everyone is. One of the things I do is try and tell people about the urgency of the timescales, and that these things aren't far in the distance, and they're not pipe dreams either. That's actually happening now, and we'd welcome sort of any conversations about production, and so would the government, and so would all our fellow sort of gas distribution networks and national grid around the country. We'd probably talk to hundreds of people over the course of sort of the year about how we're going to do this and how we're going to work together. So yeah, it is happening, but it does need the government to stimulate it as well.
Right at the beginning, we talked about this blending project that you're also overseeing. So HyDeploy, if I named it correctly. So tell me a bit about that. So that's the kind of the stepping stone, I guess, into a full hydrogen deployment around the country. So tell us a bit about that project and the status of it as well.
Yeah, sure. HyDeploy is a project that was started off by one of our fellow distribution networks, Cadent, down in Keele University in Leicester. And they started off on the university campus, injecting up to 20% hydrogen into the gas network there. And that trial's been ongoing for quite a few months now. But what they wanted to do is move that out from a sort of more controlled environment into the public domain. So we've got a project called HyDeploy 2 that I look after, that's based up in a village called Winlayton, which is just in Gateshead near Newcastle. And we're building a plant at the moment on our site at Low Thornley that will become operational in the first quarter, at the end of the first quarter in 2021. So, by the time we get into the end of March, April, we'll be blending 20% hydrogen into about 700 houses in this village in Winlayton. We've already been round every house. We've done gas checks, checked all the appliances, relayed lots of pipes and got the network ready, put new infrastructure in. So we're really excited about it. We're literally a few months away from doing the first sort of full-scale hydrogen blend into domestic properties in the UK. So that is a stepping stone to being able to do 100%. It's also, though, actually part of Boris's 10-point plan. And in that plan, it does say we want to have a hydrogen sort of village, if you like, running on 20% blend by the end of 2023. And that's what we intend to do. We should be able to meet that objective. Blending hydrogen into a gas network is a sort of a low regrets thing. To change a network over to 100%, there's like no turning back, really. You have to produce the product, put it in the pipes, and there's no real way of reversing it unless you actually stopped completely and converted it back. So blending, anything up to 20%, you can put into a gas network, and if for some reason there's an outage of the equipment or something happens, then the gas network still flows and everything carries on, and customers don't get sort of disadvantaged. So it's a fantastic way to do some decarbonisation in a more of a no regrets situation, and it's low risk, and it will teach us a lot about production and about how we do things while we're looking at doing the more complicated sort of 100% trials. So yeah, it's fantastic, and we're really looking forward to doing it. And I'm sure once we start flowing hydrogen into the network, there'll be plenty of sort of publicity and things about it, and social media stuff. So we're really looking forward to it. Yeah, it's quite exciting.
Yeah, very exciting. Exciting to have both of those projects under you. I'm sure you must be, I'm sure your time is not your own at the moment, but thank you so much for just giving us some time to talk through the projects. And I will confirm that website and add it to the show notes so that people can come and have a look. But thank you, Tim. Thanks so much for giving a bit of time on this Friday afternoon. Much appreciated.
No, thanks, Alex. I've enjoyed it.